Hi, everyone. Thanks for joining us for today's webinar. We're going to be starting in just about 1 or 2 minutes, so we'll talk to you real soon. All right, hello everyone. Thanks for joining us for today's webinar, Releasing Better Devices Faster with CloudBees Accelerator, or How to Complete 400 Years of Work in 1 month. Just let everyone know a few things up top. One, we are recording. So if you have a colleague who was unable to join, maybe you need to leave early, you will be able to view this later on. 2, we can take questions. We will have time at the end. So as soon as you think of one, even if you think maybe we might answer it during the course of the presentation, please feel free to put it right into that chat. It's always good to know people are looking to know more about. At the very end, after I close this out, a very short survey will pop up just asking what you thought and what you'd like to learn more about in the future. Beyond that, I don't want to take up too much more time. So we have 2 heads of the product team here at CloudBees. I'd like to present to you, and they will let you know who they are. So why don't we go to the next slide, and Tim, do you want to kick us off?
Sure. Hi, I'm Tim Johnson. I'm Director of Product Marketing here at CloudBees for the Accelerator product. And with me, I have Mohan Dattatreya, who is from our engineering team, from the product team.
Hi, everyone. I'm excited to be talking about Electric Accelerator with you.
So great, and thanks everyone for being here again. Wanted to just explain a little bit about what that subtitle is about how to do 400 years worth of work in 1 month. That is based on data that we've collected from our customers using Accelerator for the month of May this year. We had about 25 of our customers do something like 419,000 builds in the month of May, and the on the clock it was about 83,000 hours, but it was, if they had done it normally the way they'd been doing it, would have been 3.4 million hours of time waiting for those builds to complete. So you think about how much innovation's happened in 400 years, like with GPS. You go back 400 years, you wanted to know where you were in the world, especially if you were in a boat. You threw a chunk of wood over the side and counted how fast the rope paid out. And then you took a shot of the sun and hoped that you were correct. And now anybody's got GPS in their pocket. So what type of innovation are you passing up on, or are you waiting to have happen while you're waiting for builds and tests to complete? So that's kind of the setup. So we'll go right into this. And you know, Mark Andreessen made this quote about every business is a software business about 8 or 9 years ago, and it's really true today. And I would argue that it's more businesses are becoming device businesses, but that's we'll talk about that in a minute. One of the other comments, or the rest of the comment that Mark Andreessen mentioned when he said this, every business is a software business, was talking about the necessity to make cycle times faster. how quickly can you not only get to market, but how fast can you get to learning, that concept to learning, and any impediments that you can remove from that'll make things go faster will help determine who's going to win and who's going to lose in whatever market they happen to be in. So let's take a look a little bit about faster builds and test times and how that impacts production and development. And this may relate directly back to situations that you're facing. I know there's a number of people on here from device manufacturers and things like that. So we've seen build times, 14 hours. We've seen build times as big as 24 hours. And from a production build, that isn't going to build overnight. Your developers aren't going to, it's going to make it impractical for them to do any kind of rebuild before check-in. So that means one iteration is about every 2 days, maybe, not even every day if your build is really that long. So if you do automation, you start putting in things like Jenkins, you put in Flow and start automating that process and get some of that down, getting it down to 6 hours. Well, that's a pretty big win, but that's an overnight build if you're waiting for that code to get done so you can start testing and doing work on it. Again, it's still not practical to do a rebuild from a developer standpoint. If you get it down to 2 hours, now you're looking at maybe a same-day fix. If the build breaks or if you got some bad code in there, if it takes 2 hours, okay, now you're starting to move a little bit faster. You can do a couple of iterations in a day. Developers are still not all that likely to do a rebuild before they do check-in because it's still, it's a 2-hour time penalty for that, and they got to switch contexts. They got to be doing something else while that build is happening. But if you get it down to 30 minutes or less, now what you're really doing, now you're really starting to do continuous integration. Your developers can do full rebuilds before they check in the code. And if you can get the builds down to 5 minutes or even a minute, those developers can stay focused. They can stay in their zone while they're developing, so they don't have to switch contexts and start thinking about something else. And there's data to show that if you're in a creative mode, if you're in a creative mode, really focusing on something, and you get disrupted or you have to change to do something else, it takes a good 20 minutes to a half hour to get back to that same level of creativity. So the more that you can do to make those builds and those test cycles as well go faster, the more creative your engineering team is going to be as well. And another way to look at it is that if your builds are taking longer than 30 minutes, there's nothing continuous about that. So we look at CloudBees Accelerator as really your bridge to get to that nirvana of continuous integration. So, the other way to look at it is, how much time are your developers, how good are they at ping pong? How good are they at foosball? This cartoon's been around for quite a few years and it's still accurate, especially when you're dealing with things like Android builds, AOSP or Yocto or embedded Linux. Those are 4, 5, 6, 7, 8 hours. That's a lot of time not being creative. So we're going to take a little bit of a look at what's going on in the market. Why these build times so big? And in one way of looking at it is we've really entered the device age with smart doorbells and smart pens and all the intelligence that's built into cars and everything else that's in our daily lives. That code base is increasing. In fact, there's some data here that a new Mercedes car has more code in it than an airplane. And if you look at, as an example, you look at the size of the code base just for Android, the operating system, the AOSP, it just keeps going up and up and up and up, and there's no break in the foreseeable future, because more and more intelligence is being demanded of these devices, more and more features are being demanded, so that code base has to grow. Well, while that code base is growing, build times are growing right along with it. But at the same time, competitive pressures are increasing as well. So everybody's got to go faster and faster and faster. But now you're getting penalized with these new operating systems by adding new features and so forth. So it's not a fun situation to be in. The other factor that's going on is with that code size increase, that code base increase, the complexity of the builds themselves is increasing as well. And this is, in a lot of cases, being a build engineer is I like to term it, it's one of the black arts. It's not a skill set that is very common, and a lot of times that is pushed down to the developer to manage their own builds. And so it's getting harder and harder and harder for developers and build engineers to manage those builds. So there's a number of things that people are doing to try to shorten those build and test cycles. But we really see those as temporary or short-term fixes for what is a really complex problem. So one of the things we see is naturally, if you can parallelize those builds, if you can distribute that build across more than one core or across different resources, you should be able to get some speed up. So that's true, except that that's really hard to do. There are a few open source tools out there like distcc that can assist a developer, but they don't really work across a network. They're very hard to manage, and it requires a very specific skill set. So you're actually asking your developers to take on another skill to do their job, and that's not a skill that you're actually hiring them to do. You're hiring them to be creative and to innovate. So one of the other things is, well, let's just buy more hardware. If your build is slow, you're probably, you obviously don't have a fast enough processor. So let's get you a bigger workstation or bigger servers and so forth. And that's actually a never-ending story. It's a money pit at the end of the day, because even though you buy more hardware, you might get a short-term speed up, but over the long run, we don't see any significant changes in either build speed, and we actually see infrastructure utilization fall. So the bigger the machine is, the less it's actually getting utilized. So the less return you're getting on your investment on that. Another thing that's really scary is you can cut down the number of builds and tests. And if you're actually, doing that, what you're doing is you're asking your customers to become your QA department, which is kind of scary if you're looking at automotive devices like braking management systems or aircraft control systems or things like that. That's not really something you want to do. But also, the longer it takes to do builds, the more cautious your developers become, because they don't do as many builds as they can before they check in code, and it actually changes their focus from being innovative to being right, and that actually slows down development. It's not a situation that you want to find yourself in. And the last thing is, we also find this from a lot of people we talk to, is well, that's how long it's going to take, so that's what we got to do. So our developers get really good at ping pong, but your competitors probably aren't taking that viewpoint, so they're looking for different things, different ways to speed up those CI cycles. So what if there was a different way of doing things? Rather than doing it manually, you had a system that could intelligently distribute that workload, distribute those jobs across either what's on your workstation or what was on the network or even in the cloud. And that way you could optimize those dependencies, and you could also guarantee the correctness of those builds. So if there's any missing dependencies, it automatically adjusts it so the build doesn't break itself. Another thing would be if you could avoid rebuilding stuff that didn't need to be rebuilt. Then you could obviously eliminate a lot of redundant work. So you're not wasting time waiting for stuff that didn't change. Another thing would be to grab whatever resources you need as you need them, spin them up, do the build, and then spin it down. That way you could do faster builds on significantly less infrastructure. And with Accelerator, we typically see it's less than half, usually around 25 to 30% of your infrastructure, you can get those those speed ups. And then what if you also had the analytics to go in and see how you could better do capacity planning, do better fault analysis, and really see deeply into what's going on so you can constantly improve your results, because that's what DevOps is all about, is more learning, not only from the code itself, but from the processes. And that brings us to CloudBees Accelerator. So it gives you more time for that experimentation, doing more development cycles per day by massively speeding up those build and test times. So instead of slow builds and tests, you got developers waiting, drinking coffee or taking long lunch breaks. Now you can deliver better software, better devices in much less time. You can significantly shorten that concept to learning, or that time to market cycle. Instead of constantly trying to throw more hardware at the problem, like $25,000 workstations, now you're getting the most utilization out of your infrastructure, both cloud and on-premise. And instead of builds being hard and trying to optimize resources being a very difficult process, now you got the visibility to see into everything there and manage it effectively. So that's the introduction to it. What I want to do is I want to hand it over to Mohan here for a few minutes to talk about how Accelerator works. So here you go.
Thanks, Tim. So you must all be wondering, this sounds too good to be true. You can go faster, 20 times faster. You can use less hardware. How does this work? And can you give me some proof points? So I'd like to take just a few minutes to walk you through how it works under the hood and how we speed things up. So the first example I'd like to use is, assume you have a build that has 6 different steps, if you will. And if you're running them on a single computer, it takes you 40 minutes. Now, if you were able to distribute that same build across multiple machines, in this case, let's say 20 machines, then you might be able to cut that down to 2 minutes, because you are now able to parallelize the work that happens in that build, which was running sequentially. You're now able to do all of that work in parallel, assuming there is a 20-way parallelism present. So that's the first way that Accelerator can help you go faster. The second way is, every time you run a build, let's assume you're using a GNU C compiler. So Accelerator can look at how you are invoking that compilation, what the command line to the GCC is, what the environment looks like, and once the initial build is done, it will deposit all the artifacts, all the binaries that are generated by that build in a shared build cache. And the next time around the build is run, it looks at whether any of those compilations are identical to what was done on the first build, and you can just reuse them by replaying them from cache. So you can see here in this example that you had a build that took you 60 minutes, and now because it's able to replay 3 of the 4 components that it was building directly from the cache without having to actually do the work, it's only going to take, the build is only going to take 15 minutes here. So the goal here with caching is to eliminate work that is redundant. There is no need to recompile a module that you have not updated. And with our job caching technology, we are able to recognize that and take advantage of. So that's another way how Accelerator can help you to not only go faster, but also to save on CPU cycles, because the work that you are able to avoid means that you don't need as many CPU cores as you did initially to do the same work. So those are the two ways, just to recap. One is distribution across cores, and the second one is through caching. That Accelerator helps you to go faster. The second point is, Tim already alluded to this, what makes Accelerator unique in the build acceleration space is the fact that it has the ability to detect when you have dependencies that are missing. So what do I mean by that? So if you look at this picture on the right-hand side, you have source files. Let's assume you have header files at the very top that are included in C files or your CPP files. And when you run builds with, or you run compilations on those, you will create intermediate libraries, and then those intermediate libraries get linked into the application. So you can see there are many dependencies between the various pieces of source code that are being linked together to create the final application. So one of the things that might happen is, assume you were using a make file, that there might be dependencies that are not specified between those modules, which is critical to creating a correct final product. And those dependencies may not matter when you're running your build on a single machine, but when you're distributing it across multiple cores, across multiple machines, then you could have one of two things happen. You could have your build fail because those dependencies were missing and you build things in the wrong order, or it might silently complete and build the wrong product, because just imagine there was certain dependencies that were critical to creating the object in the right order, and those were ignored, then you would end up with binary. So I guess the net here is that it's possible to go faster by using some open source software out there, but you have no guarantees that when you are using parallelism that the final output is going to be correct and it's something you can trust and use in your releases, right? So the promise behind Accelerator is that it can automatically detect these dependencies because there is an underlying distributed file system which is watching in which order these jobs are being run, and whenever it detects something is running out of order, it automatically fixes it. It records the missing dependencies in a history file that you would use for subsequent builds. And so that's how it ensures that builds are not only faster, but they are also run in an order which is guaranteeing correctness. And what I mean by correctness is that it is guaranteed to be identical to what you would get if you were running the build on a single computer. And so the benefit of this, and this is why large corporations are already using Accelerator for their build clusters, is that you can use this safely for not just for your CI builds, but for your release builds as well. Finally, so Tim also talked about we can not only make things go faster, but we can also make more efficient use of the infrastructure. And so the question you might ask is how. So I assume you have build farm or several servers that are of different configurations. Some of them might be 8 core, some of them 16 core, 32 core servers. So what you do with the Accelerator is when you combine them to create a cluster, we creating a virtual supercomputer which essentially pulls all the cores from all of the machines regardless of which server they belong to. And these are available to any build that is run through Accelerator. So just assume you have now a user has launched an Android operating system build, and it's gone and grabbed cores from several machines. This is an automated build, and then you have a developer coming in and running another build, and he's allocated a different set of cores across a different set of machines because there are cores available. And this is part of the smart job scheduling that's available with the Accelerator Cluster Manager. And then let's assume that you have a priority build comes in and there aren't enough cores available at that time in order to get the release build out as ASAP. So you cannot just load balance the cores across the different builds, but you can also specify priority, right? So since the release build is a priority, it can preempt the Android build that was running and kick the jobs, subsequent jobs off for that Android build, and the release build completes getting the the full allocation of cores that it requested at the start of the build. So that's essentially, in a nutshell, how the whole process of core allocation works. What we call this fine-grained core level allocation. This is again something that you would not get if you were using some open source software solution for distributed compilation. Again, the fact that we have job cache technology, which I just talked about on the couple of slides ago, allows you to eliminate doing redundant work. This is another way you can optimize on your infrastructure. And finally, if you're using cloud CPUs like EC2 instances or GCP or Azure, and we have support for all of those, you can configure your resources so when you launch a build, those instances are spun up on the fly, and when the build is completed and they are idle for a certain period of time, then they are shut down automatically. So you don't have to worry about having stale instances sitting around and you being surprised with a large cloud build. Okay, so you said this all sounds great. How can I try this out? And what's the process for me to actually integrate Accelerator into my build environment and to be able to see what kind of results I can get? So here's an example. We had a customer, we went in and they had a GNU Make build that took them 1 hour and 10 minutes, and this is pretty common. What we mean by serial build here is the build was running on a single machine, and hence everything was executed serially, or one after, the jobs in the build were all executed serially or one after the other. We went in and after replacing GNU Make with eMake, which is our client-side program, which automatically provides the distribution. The initial build took 43 minutes and 49 seconds, and you can see the visualization on the right-hand side, which is from Electric Insight. That's a tool that allows you to see how your jobs are being parallelized. You can see the various, 10 rows there. Each row corresponds to work happening on a different agent or on a different core, if you will. And each of those rectangular small boxes are pieces of compilation. So you can see it's fairly tightly packed, and you got about 20 minutes of saving. And then your question might be, yeah, that sounds good, but is that all Accelerator can do? And so the answer is no. This was the initial build, like I talked about. When Accelerator goes through the initial build, it discovers that there are things running out of order because of missing dependencies, and that's what we call conflicts. So this build had 778 conflicts, and those jobs had to be rerun to ensure that they are built in the right order, and these dependencies were recorded for subsequent builds. So the next build was run, and voila, right? So we went from 1 hour and 10 minutes down to under 5 minutes. That is a 12x acceleration, and you can see how tightly packed these jobs are on each of the agents. So across each of the 10 agents, you can see the build completes within 5 minutes. And so this is the secret sauce, if you will, is that we're not only able to discover the missing dependencies and fix them on the fly, we can reuse them for subsequent builds and be able to use that information to speed up subsequent runs. Finally, the question you might ask is, what if I could throw more CPU resources at this? Can I go even faster? So the answer is you can use the inside of Electric Insight, there is a electric simulator report where you can set up, here's how many agents I want to use for this build. And since you've already run the build through Accelerator, it already knows how long each of those jobs take, how much parallelism it has, what the dependencies are, and you just plug the number of agents you want and you can get a graph out. And you can look at this graph and say, hey, it looks like I'm at 10 agents, and you can see the simulator is pretty accurate in predicting that, with 10 agents, you'd get to 4 minutes and 56 seconds. But if I were to go to 20 agents, I could reduce it to 2 minutes. So that's a choice you can make as you are deciding how big a cluster or how many agents you would like to use for each build, depending on what speed targets you have, and use that for your planning the size of the cluster. You also need to figure out how many concurrent builds you want to run at the same time. So that's kind of in a nutshell how Accelerator works. There is a trial version available on the website. You can download it, you can give it a try, and there is, if you have any questions, you can reach out to us and we'd be happy to help you with, trying out a proof of concept.
Okay, so thank you, Mohan. So I want to just, as a side-by-side comparison, GMake or GNU Make is a very common tool out there that we replace. And this is the dashboard we put together on running some builds side by side. And, in this particular case, we're seeing, 16 time speed up in those builds. And at the same time, it's 10% of the cost. So instead of about $22 per build or per 1,000 builds, now it's less, it's right around $2. So you get some significant cost savings. And that savings represents not only fewer servers run, but also heating and cooling costs and other administrative costs that are in there. So you can get some pretty significant cost savings with it as well. So in summary, CloudBees Accelerator lets you, we eliminate the waiting, you can do more innovation. We accelerate those builds significantly, 20 times faster, sometimes more on that. You're optimizing your physical infrastructure and cloud infrastructure, as well as having the insight to see where problems are and how you might be able to fix them. So now I want to spend a little bit of time on some customer examples, because the proof is always in the pudding. The product's been out for quite a while, over 15 years now, and we've got a number of significant customers that have been using it for a long time. If you're using an Android phone, probably you're benefiting from Accelerator. As you can see, we've got Samsung and LG and Huawei and Motorola, so forth are all customers of ours. We are also starting to see some growth into other areas, what I alluded to earlier around the devices, automotive, aerospace, healthcare, with a lot of robotics and other types of intelligent medical devices that are out there. Zebra and Magic Leap are customers of ours, as well as in the financial services area like Square, Morgan Stanley, and so forth. And in the financial services, we talk a lot about devices, but in financial services, they're doing a lot of our customers there are doing very high-speed transactional type of applications like foreign exchange, trading desk, stuff like that. Those applications tend to be written in C and C++ for performance reasons, and that's where we're getting big performance gains with those as well. But I want to talk about a couple in particular. Zebra is a big player in the intelligent Android device space. They have stuff in healthcare and manufacturing, warehouse management systems, retail scanners, things like that, hospitality and so forth. And part of their marketing, their value proposition to their customers is helping their customers go better, faster, with better performance. And so they're actually live by that by using Accelerator. They came to us and they had a couple of problems. One was just the slow build time. But the bigger issue for them was the variation in the build time. It was anywhere from 2 to 5 hours per build. They never knew. There's all sorts of factors that went into that. Availability of resources and changes to the job and so forth. And I think Mohan wants to add a little bit here.
Yeah, so I just wanted to add a little color here, right? So the typical scenarios we've seen for customers who have long build times and how they handle it is they buy a bunch of really high speed, high core count server machines, and then they divvy it up amongst the developers. They say, the 12 of you are all SSHing into this server, and you're running your builds there. And then depending on how many servers are on that machine at that time, your build time might be 2 hours, right? If you're able to get hold of all the cores on that machine, or it could be 6 hours, depending on how many of your other colleagues are logged into the same machine at the same time. So that's how we have seen. It's kind of like time sharing, and you're manually divvying up the servers and asking developers to use that. So if that is a scenario that you are have and you feel that it's not scaling for you, it is not working for you, that's the problem we solved at Zebra, where we said you don't need to no longer have separate pools for separate teams, and instead you can combine all of your resources and create a single cluster, a unified cloud, build cloud, where we'll automatically take care of load balancing amongst all of the builds that are happening at the same time. And you can set up policies for that. And that's how we were not just able to get the build faster, which they cared about, but they also cared about the variance, right? So you can see, like Tim mentioned, instead of 2 to 5 hours, it went down for something between 10 to 23 minutes, right? So that's kind of the big takeaway for them is, IT no longer has to deal with every new project that is happening, developers coming up and saying, build times are too long, I'd like to buy, I need a few dedicated servers for my projects. Instead, they can say, I want you to use this Accelerator build service. And so that's the more efficient and scalable way. That's what Zebra ended up finding out by using Accelerator to be able to meet the demands of their dev team and control the infrastructure costs.
All right, thank you. So I want to talk a little bit about Square. They have totally disrupted the payments industry in North America here. And their mantra is they want everybody to participate. So they've got to build all these devices, cash registers, terminals, the Square reader. Even my Boy Scout troop uses those for fundraising these days. Everybody's got a Square reader. Everybody can make a transaction via credit card these days. And so they're under huge competitive pressures because they're putting competitive pressures on the Verifone and NCR and IBM and other players in the space. And so they came to us with, they also had very similar issues with variable build times. And again, they had no idea how long it was going to take. Excuse me. And now we get their builds down to about 11 minutes on average. And they were trying to use Ccache, which is another open source tool. So we go 3 times faster than Ccache, plus it's all automatic. They don't have to have anybody managing it for them. So they starting to use more on their get more utilization out of the machines. They can use those machines at scale, and they really wanted to modernize their applications and how they ran into the cloud.
So I just wanted to add to what Tim said, right? This is a pretty interesting use case for Accelerator is Square, had all of their build servers on premise. but at the same time, they were so security conscious that they wanted to ensure that the payload, if you will, or the source code that's being sent from the client machine to the various agent machines was secured and authenticated. And so we were able to leverage, we have this secure mode where we can use TLS, and then the data that's sent from the eMake machine to the various agents is completely encrypted using SSL, and they were still able to get pretty amazing results. So the key point here is, if you have an IT team that's concerned about security, we've got all of the security protocols in place in the product while we deliver the performance.
All right, thank you. Finally, Cisco, we want to talk about them. They really don't need any introduction. If you've clicked on a website, you've used Cisco in the background somewhere for a switch or a router. They have 8,000 developers, and their builds, one of their builds was something like 20 hours long, and that's bad enough. That's like a 3-day cycle for getting feedback. And very often their builds were going, like 18 hours and then failing, so they had to restart the whole thing from scratch all over again. So not only was that slowing things down, but the developers kept screaming for more and more hardware. I need a bigger workstation, to the point where they were asking for a $25,000 workstation, a 34 core or 32 core, 80 gigabyte workstation. And that's like $25,000 a piece times 8,000. That doesn't work. And so they initially were looking at setting up a whole data center dedicated to just doing builds. And then with the adding Accelerator into their system, they were actually able to eliminate a data center. But they also, this is where I talked about earlier, they showed that the bigger the data center, the more hardware that was available, the less it got utilized. So the best that they could ever get was 50% utilization of all that. So by adding Accelerator and using it across all these developers, they're getting huge savings in time, in speed, and cost, but they're also actually able to eliminate a data center altogether. And that was over $3 million a year, and then 3.2 gigawatts of power they just had to eliminate out of their operation budget. So they had significant results on that. So that's what we wanted to talk about with CloudBees Accelerator. We want to open this up to any questions right now. We've got a few minutes left before we close it out. Max, do we have any questions?
We sure do. Let's start with one here. So, what kind of build systems are supported?
Excellent question. What kind of build systems? So, Tim, let me take that. We support Make, which I mentioned quite a few times during our presentation. We support Ninja, which is a build tool from Google that's used in a lot of the Android operating system builds, and it's used by a lot of modern projects. We also support Visual Studio, and so these are the primary. So that's what's supported out of the box. We also have a mode where if you have any build tool that is multi-process, meaning you can launch up many instances of that build tool, we have a way to be able to capture those processes and execute them by distributing them across the cluster. So we have a separate mode that many of our customers are taking advantage of for other build systems such as Jam and Sconce. So that's kind of the environment that we play in.
Okay, thank you. Any others, Max?
Yep, let's move on to this next one here. And just so everyone knows as we go, you can continue to ask questions throughout this time. So if you think of anything, please feel free to go right ahead and ask. Would Accelerator and Jenkins share the same clusters as Jenkins agents? Okay, so just to clarify, it can
use the Jenkins agents, but the typical deployment scenario is the following, right? So you have a build that is launched as a step within a Jenkins job, and that step is executed on a Jenkins agent. So that's where the accelerator client piece or eMake would be running. But in order for you to parallelize your build across multiple cores, you would spawn up from a Jenkins slave a number of different agents that are required for that build. So the answer is we can work on the Jenkins agent, but there will be a separate set of accelerator agents needed to parallelize the build, which is just a step in a Jenkins job. Does that answer?
It should do.
I believe so. You know, if it didn't answer that for anyone, please feel free to follow up. We can touch back on it. Otherwise, let's move on. What languages or operating systems does Accelerator work best with?
Excellent question. So that's we mentioned Android AOSP, frequently throughout. So that's probably already answered. But any the embedded Linux, automotive grade Linux, Yocto project, things like that. So if you're putting something on a device or something that requires a battery or a power cord, you're probably putting an operating system on there like Linux or Android. As far as languages, Mohan mentioned Visual Studio from Microsoft. Also, C and C++ is languages that we work effectively with.
Okay, so I'll just clarify this. Platforms, Linux, Windows, and Solaris. So it really doesn't matter if you are on one of those platforms. Accelerator is supported on your platform. It doesn't matter which variant of Linux you have, whether you have Ubuntu or Debian or Red Hat. We have support for the various flavors of that. You can check out our platform support matrix for that. And then as far as languages, while we do talk about C and C++, I just want to reiterate that what is most important is the build tool. So let's give you an example. So if you have a make file, and the make file could have compilations for C and C++ in it, it could have compilations for Java in it, like it does for the Android build, and all of those can be accelerated. So the key part is just imagine that what are the railway tracks on which accelerator can run, right? So you can, what the payload is, what you're carrying within that thing is very agnostic to that.
Great, thank you.
All right, this is a bit of a follow-up on that. It looks like, would Accelerator support Java builds using Maven and Ant, or could it be customized for that?
At the present, we do not support builds that are run with Maven and Ant. And the reason for that is basically it operates within a JVM. We do have plans for looking into that in the future, but at the present moment, those are not supported.
Okay. What benchmarks are available for Android?
We have quite a few. We have a number of customers that their Android build was 4.5 hours, 5 hours, and we get it down to 30 minutes or less, sometimes 15 minutes, stuff like that. Actual results will vary a little bit, obviously, but the multiple X improvement in build times is pretty easy to attain for us.
All right, looking at what the next one. So it looks like a few more. What types of tests exactly does this accelerate?
Good question. There's, I'll answer it on a high level, and I think Mohan can go in a little bit deeper. But primarily, the tests that we accelerate are things like unit testing and code analysis, things like clockwork and stuff like that. Again, those take a long time, and those cycles can be multiple hours, and we can get them down very short, hour or so. Anything else you'd like to add, Mohan?
Yeah, so the answer here is that there is a, if you have tests that can be executed from the command line, and if you have a way of enumerating all those tests and running each of those tests individually, then those are good candidates for speeding up with Accelerator. We have found that because in the CI, you're typically running builds and unit tests together. Unit tests are the natural extension to using Accelerator when you're already using it for builds, but it could accelerate any test as long as it meets those parameters that I mentioned. You should be capable, the test framework that you're using should have a command line interface. You should be able to break up your tests into a number of components, because that's essentially what you're parallelizing. And then you should be able to execute each test case individually, as opposed to running the whole test suite. If those criteria are met, then all of those are, you can, with a very little bit of work, be able to adapt your tests to integrate it with Accelerator.
So another way of thinking of it is, if you use Accelerator on your test cycle will only be long as the longest individual test, rather than waiting for all of them to run together or run sequentially. Any other questions?
All right, looks like one more, unless we get some more in the meantime. Before I ask this, just to remind everyone, there's a very short survey that'll pop up at the very end, just asking what you thought, what you'd like to learn more about. And beyond that, thanks for joining with us for this, and let's do this question. Is the system able to manage mixed build systems? So for example, Yocto plus Make plus a homemade glue.
Yes. Yeah, absolutely. In fact, that's a perfect use case for Accelerator, because that's a very complex environment that you're talking about, and the more systems you have, the more of a skill set you need with your build engineers and your developers, and we can take that level of complexity away from people.
All right. Looks like that's about it for today. So before we sign off, Tim or Mohan, is there anything you'd like to say here at the end?
I'd just like to remind folks who joined that if you're interested and you'd like to give this a try, you should go to our website and download the trial edition, and let us know, how things work out for you.
And I was going to say the same thing. And thanks for joining, everybody.
All right. Thanks, everyone. Thanks for joining along with us. We'll talk to you again real soon. That survey is about to come up, and we hope you all enjoyed it. Talk to you later.